Hello, hello. Critical number, a critical number. What is a critical number? Well, a critical number is a number C such that the derivative is 0 or the derivative just doesn't exist. Why do we care about such things? Well, let's do a little look at some possibilities. There are 3 possibilities. You have, let's say, 1 f prime of C is 0, 2 f prime of C just doesn't exist at all, and 3 f prime of C is non-zero, so exists and is non-zero. So if we're looking at a function, we're often interested in finding when is the function achieving a max and when is it achieving a minimum. And it's only going to happen here and here. Okay, so f prime of C equals 0. You can see how that could be a max. You can have a top of a hill like that. F prime of C does not exist. That could be also a max or a min. It's a bit hard to understand. Let me say it like this. F prime of C does not exist, meaning this limit h goes to 0 of f of C plus h minus f of C. Okay, so this limit does not exist. That's what we mean technically. Okay, but what can happen, what a possibility is you could have a function that behaves kind of strangely. So you could have a function, and we'll see this later, a function that goes like a sharp edge. So you could have like a sharp edge happening here. Now you can see, hopefully you can kind of see why the derivative doesn't exist here, because your slopes are positive and then all of a sudden negative. So it's that sudden change, which in a sense, vaguely is causing this limit to not exist. So anyways, saying that f prime of C does not exist, what we literally mean is that this limit doesn't exist. But it could cause a max or a min. Okay, you could have a max like that, or you could have a min like this, and these things do happen. Okay, f prime of C, this case, is not going to produce a max or a min. Okay, so no max or min at C. And this is by Fermat's theorem. Okay, Fermat's theorem told me that if the derivative exists and I have a max or a min, then I got to be in scenario number 1. Okay, what is all this about? Why am I talking about this so much? Well, I'm trying to motivate the definition of a critical number, okay? So again, if we are trying to find the max or the min of a function, we only have to look in these 2 places. And that will be our approach. So when we're analyzing functions and trying to find max and min, we're going to be looking at critical numbers. Okay, let's do an example now. Okay, find the critical numbers of this function. So I take a derivative, and I'm going to find out when it's 0, and I'm going to find out when it does not exist. So what is the derivative? F prime of x is, well, I do product rule. So 3/5 x to the negative 2/5 times this guy unchanged plus x to the 3/5 times the derivative of this bracket, which is -1. Okay, what I usually do is I usually factor out the smaller power of x that I see. So I have power of x here, power of x here. I'm going to factor out the smaller one. So I'll factor out x to the negative 2/5, leaving 3/5 4 minus x plus x to the, well, let's do it the slow way. So I had x to the 3/5, and I'm dividing. When I factor this out, I'm dividing by negative 2/5. So working this out, hopefully not making mistakes. Now this is nice. This is just x to the 1, okay, which is coming from the fact that you have 3/5 subtract negative 2/5, which is x to the 1. X to the 1. So that worked out nicely. Almost there. So I got 12 over 5 minus, combining these gives me negative 8 over 5. All over x to the 2/5. And what can I factor out? Why don't I factor out 4 over 5? Leaving me with 3 minus 2x all over x to the 2/5. And, oh, I suppose we could make it a little bit prettier, like so. Okay, there's my derivative, f prime of x. Okay, critical numbers. First one is, the first category of critical number is when you have f prime of x equals 0. So you have this thing equal to 0. So how can a fraction equal 0? The numerator must be 0. So 3 minus 2x must be 0. So 3 over 2 is x. And the other category of critical numbers is f prime of x does not exist. It's like a Wn. So when does this fraction not exist? Well, it's when the denominator is 0. So that's only going to happen when x is 0. Now I need to check something a little bit subtle here. To be a critical number, you have to be in the domain. Recall, to be a critical number, C has to be in the domain of the function. Okay, so we have to just make sure that our x values we found, this guy, 3/2 and 0, make sure that they're in the domain. And just by looking at them, I can see that taking x equals 0 and plugging it in here Yep, that's okay. And also the 3/2, that also works here. Okay, so these are my critical numbers. There's no problem here.